Everyone. This video will be part of a upcoming series on C++ keywords. I don't want to, I'm not here to teach you the C++ language. There's a lot of videos in it. I mean, unless if people want, but I think that I'm not contributing and doing anything new. I haven't seen any content on keywords specifically because, like, yeah, they teach you the language and they give examples and kind of, in order to learn a new language, you got to fiddle around with the actual compiler with an IDE or something like that, and make a couple of programs, some small scale project, and you're good. You've learned the language, but no one actually goes step by step teaching you the keywords. They just teach you, okay, this is a class tantamount to Java, and a struct and class. Okay, class by default is private, struct is public, static, const. So they will go and tell you how to actually build out components. Okay, so and they may make comparisons to other languages, like, oh, how Java in this is like that. You have public, private. So in C++, it's like this, or So I'm not here to teach you the language in a language teaching manner. I'm gonna just throw it at you, all the C++ keywords in a very enclosed tutorial series. So that means it's keyword by keyword, and hopefully you learn something, because a lot of us who know C++ fairly well are not familiar or never going to use the keywords. But it's still good to know, because you can just be more confident in the language that you already know and are familiar with and are coding daily on. So I think that this could definitely be a benefit. So let's begin. So right now I'm going to make a video on extern. The keyword extern exists in C also, but I'm going to give, it's also C++ keywords tutorials. So what is extern and what does it do? Is it complicated? It's not complicated, by the way. But what does it basically achieve? What does it solve? So first I'm going to present to you a problem. And the problem is bad in practice, but it's still a problem for those people who do these things. So let's just create a file and call this main.cpp. And I'm just gonna using namespace, so I don't have to type the namespace out every time. And okay, this is the basic structure of main, right? Okay, now what if I declare a global variable? Now this is what I mean that it's bad in practice. We never declare global variables, but what if I do? So gvar is global. So that means if I say gvar, let me just make this more meaningful, I'll say 72. So if gvar is, this will compile successfully, and gvar is 72, so it's going to print that. So I'm going to say g++ main.cpp, and this will compile. And then I want to say a.out, and we see 72 gets printed. Okay, now let me create another file. All right, and let's call this, let's call this extern.cpp. Okay, and I'm gonna have same stuff here. So I'm assuming you already know what include, using, namespace. I mean, that's just, I'm starting from extern because it's probably more of an unfamiliar keyword that people don't use, but just to go over everything. So I am going to go over using and namespace and where it applies and all the keywords, but obviously, you gotta start somewhere. So let's just define this a sum function. And let me just modify gvar to 5. This will not compile. And in fact, Clang Vim autocomplete, you complete me plugin gives me an error. Okay, and it shows this X on the left to show me that it is in fact something wrong. And it's not like it's not like I called the function incorrectly, so I have to fix it. No, it's something undeclared. It's a compile error. And let me just show you. So let's compile. What's going on? Oh, I don't have the bang. G++ extern, that's, oops. Extern.cpp, and boom, we get a compile error. Use of undeclared identifier gvar. And you see that was the same thing over here on the bottom. So what's going on here? Well, when I compile this file, right, gvar doesn't exist, but gvar exists here, right? So you know what? Let us try compiling let's try compiling main.cpp first and then extern.cpp into one final executable. So you might say that gvar will be contained in the file translation unit, right? But at the end of the day, will we still get a compiler? The answer is yes. Same error. Why? Because when the compiler, the way how it works is, if I have X amount of files, right? So if I have an X amount of files, every single file gets compiled individually, and they get linked as a whole. So this notion that every file gets compiled, every source file gets compiled individually, that already introduces an error, because at the time of compilation of extern.cpp, gvar does not exist. So I get an error. And even though it will exist in the future when I am down to the linking stage and then I have this final executable, so even though this is undeclared symbol, undeclared identifier, right? I have symbols for gvar that is here, right? So I will have some sort of mapping at the end of the day, but the problem is I can't get there because when I compile this, I don't know what it is. So if we can imagine as the compiler ignoring this error, and then, ignoring the error that we don't have this identifier yet, and then automatically just, putting the puzzles and the pieces together, everything will work. Why? Because gvar does exist in the compilation unit. But the problem is the compiler doesn't know that. And the compiler doesn't like when we don't have anything identified. If I say L, K, and J, this is also going to be an error for the same reason. It just doesn't know where these variables are. So how do we cool off the compiler's rejection? And what we do is use you guessed it, extern declaration. So we have extern int gvar. What this does is this tells the compiler, I know you're compiling me individually, but I don't want you to throw me an error even though you don't recognize the declaration or definition of this variable in somewhere in this file. Because in the end of the day, when we are going to link main.o and extern.o together to create a.out, we will have gvar. So automatically, whatever this is going to translate to, this variable, to some unique value or whatever, it's going to be found in the translation unit, which is this definition here, right? So that's what extern does. And let me just illustrate this for you, because if I print this here, and let's say I want to call the sum function, and then I print gvar after I called sum function, what do you think will happen? Well, first of all, we gotta have this error, right? Sum function is also undeclared because it is declared in extern.cpp. So how do I make this function available without using includes? How do I make this function available to this file when I'm compiling main.cpp? I want the compiler not to throw an error that some function doesn't exist. So how do I do that? Well, the same process, right? What do? We say extern void some function. We just create an external function declaration. And what this says is that even though I don't know where some function is now, but I will know where it is once I compiled everything and I linked everything together, and I will be able to find this function. So we have, this case is more complicated because we have two external declarations that are interdependent, right? Each one holds some sort of resource. Main.cpp has gvar, extern has some function, and extern.cpp has some function, and each file depends on each other's variables. And in order to do that, we have to use an external declaration because when I compile those files individually, they don't see the variables. So I have to use an external declaration. So that's what it does. Basically, if I have a global variable and I want that global variable, to literally be global in my whole entire compilation unit, what I'm going to do is use an extern declaration wherever I want to access that global variable. And it is the same variable. And just to prove that over here, I'm going to call some function. So I am going to predict what will happen here, right? This is going to be 72 as we saw earlier. This will change. This will change gvar to 5, and then this will just print 5, right? Because it is the same variable. And let's just prove that. So I'm going to say g++ main extern.cpp std, boom, 72 and 5, right? Now, if I compile extern.cpp, we saw that it gave us a linker error, right? Because if I compile, it didn't give us a compilation error because I told the compile not to worry. But at the end of the day, if I don't have, at the end of the day, when I'm creating an executable, first of all, I don't have a main, right? In extern.cpp, I just have a random function declaration, not a main. And also, I don't have this gvar. I told the compiler, don't worry about it. But then when push comes to shove, when I actually need that variable to build everything in a final executable, and I don't have it, then that's an error, right? So that's kind of, we're concluding that, even though I do have an external declaration, and the compiler said it's okay, but the linker says, but I don't see it, so therefore it's not okay. So yeah, basically, without the external declaration, you won't have a way to access things in order to avoid compiler errors. With the external declaration, the compiler cools off a little and it doesn't complain, and the linker may complain at the end of the day just to make sure that things are all set in stone, because if I actually don't have this definition, what is gvar equals 5? That's completely meaningless if I don't have it declared somewhere. So that's basically it on extern. I hope you understood. And thanks for watching. I will be coming out with more C++ keyword videos, going through each keyword and giving an overview of its context, how it's applicable, and all the different ways that you could use it. Okay, thank you for watching, and bye-bye.